Hello guys, Jagveer Singh back with another video of Catia V5, and this is the third video on student request. In this video I will show you how to make a design assembly. So let's get started. So first of all we will click on file, click on new, and instead of a part this time we'll go on product, double click on it. So our product window will open up. So first of all, if we are going to do it in assembly, so make sure you go to file, start, mechanical design and assembly design. If you are not already on it, you can always verify that if you are on assembly design or some other. So if you are on assembly design, then right click on product and click on components and then click on existing components. So I've already saved the files on my desktop. So I'll click on desktop and bring all these three files in. All right. So I can see that this is what my assembly so far looks like. What I want is it should look something like this right here on the screen. So I know that there is one cylindrical face, then there are going to be few coincident joints that I'm going to make, and definitely for every assembly we know that we need at least one fixed part. So we can choose any one of these. So we can either make the top part as a fixed part or the bottom part, but definitely one of these two will make most sense to make them as a fixed part. So I will start and consider with the bottom as fixed portion and the upper one as a moving one. So I can see that the bottom one have a cylinder and the upper one have a rod. So let's see. We have three parts. First, we need to isolate them. I often use compass. You simply drag and drop on the part, and when it appears to be green, it means that the selected component can be shifted or moved apart. So I want this rod part to stay here, but I want this part to be at the bottom. So I'm just going to flip it, take it at the bottom right here. I'm just going to visualize for now, whatever makes the most sense. And then from there, we can actually make the assembly go as well. So I'm going to closely relate it. I'm going to spin it a bit, something like this, close enough. It doesn't need to be perfect because it doesn't matter that much. So I'm going to fix this part. And how do I do it? I click on fix component, single click on the part that I want to fix. And you can see that there's an anchor sign that pops up, and also under the constraint, you can open and see fix is part one. So that's how we know that that particular part is fixed, right? So we are done with one step. So now the next thing is we will coincide these two, as we can see inside a drawing as well. So the base is fixed now, and this pipe or this rod goes through it. So we use coincide for the same. Click once, click on one of the rod or one of the cylindrical surface and the second part's cylindrical surface, and it will appear to be coincidental. So this is the update sign. Whenever you make any constraint, after that you click on update, it will automatically make sure that that constraint is executed. So now I need to make sure that this part is at the same angle or is basically parallel with this particular face. So what I can do is I can either click on angle with this as respect to this is going to be 0 degrees. Click update and there you go. It's going to appear something like that. You can notice one thing that I do not need to coincide or I do not need to contact these two surfaces because this has already been uh, held constrained with a cylindrical feature, with a cylindrical constraint that we used initially. So now this part is moving because this is not fixed, the base is fixed. So from the picture as well, we can see that we need four arms. Although this particular assembly is not practical because I was looking at it because of the fact that these four legs would need at least some clearance in order to be a practical assembly, which in this case it doesn't exist. So what I'm trying to say is if I look from the side, the thickness here is I can use measure between, click on one side, click on the other side, and you can see the minimum distance is 10 millimeters. Similarly, if I check the distance between these two, it's the same. It's 10 millimeters as well. Now the issue is either this particular part, this particular rod should be slightly shallow from one side. So for example, if one side of this is 5 millimeter thick and the other side is 10, it would be acceptable. But both the sides are 10 millimeter thick. So what will happen is they will coincide or overlap each other in terms of physical assembly. So that is not practically possible, but for the design aspect, it's a good practice though. So I will clarify as I will design further. You will come to know what I'm trying to say. So we need four of these. And how do I do that? So first I use compass. I just want to make sure that I've isolated this part properly. So compass can be anywhere, but it need to be moved from its standard position and kept anywhere on the assembly. So let's say if I have my compass right here somewhere, until or unless I click on that particular, like single click on the part, until or unless it's not green, it means that compass is not active. Once it is active, then you move the compass and you only control the path that you have selected, not every part. So this is one part. What I want to do is I want to copy this part four times because I need four of them. I single click, then right click, copy, go to top of the product, right click, and paste special. There will be an option as specified in product structure or break link. I will like to break link, and you can see that there appears copy one of part one and stuff like that. I can do the same thing once more. I'm going to copy these two parts, right click, copy, right click here, paste special, break link. The purpose of break link is that it's not going to keep any constraint or any relation between the parent and the child part. So any constraints or any relation that the first part had, which is part one, will not be linked with any one of these parts. So all of them are independent. So that being said, so you might be curious that where are all these parts because they're not visual. Well, they are always going to be copied on one of one another. So that's why you need to isolate them as well. So simply click on one, copy one, isolate the part, copy two, isolate the part, copy three, and isolate the part. There you go. You can do multiple things if you want to, right here, this way. It all depends on how you want things to work. Not necessarily that this is the only way of doing assembly, or there are multiple ways. Sometimes you can only copy two of them and then use the mirror command. So people use various techniques. I'm just showing you one of them. So now I'm going to do coincide once again. I'm going to click on coincide right here, update. Then I'm going to either you can use coincide or you can use contact. I'm going to coincide this with the inner side of it right here and click OK, update, right? So I also want a relation between these two, same coincide. So I'm going to coincide this part with this part right here, click OK, and then I can coincide this with the base. As you can see right now, For anything to be practical, if you think about it, right now it's right here. But after I constrain the base, you will see one more observation. If I coincide this side with this right here and click OK and click update, it's not visual to us, but now these two parts are overlapping. This is what I was talking about initially, that they are not that practical as they appear. So this is part one. As you can see that the orange part is within it. And this is part two, the copy of it, and both of them have this intersection part right here. So this part itself is overlap of two parts, which in terms of practicality does not make sense, but for the design aspect and just to get familiarized with how assembly design works, this is a good practice though. So now we're done with one side. We are going to do the exact thing with the other side as well. I'm going to apply constraints similarly. Apply here, apply there, right? We'll do the same thing here and here. There we go. Then I'm going to coincide this side as well. Coincide and coincide right here. Do it. Okay. So now I want to make sure that this is on the other side. So I also use manipulation. Manipulation is a great tool to have. Sometimes it's a good practice because you never know like what kind of features that you might need sometimes here and there. So you can always try to play with it. You see, like I'm trying to move it, but it's making an issue. So the best practice is going to be I can rotate it along one of the axes. Similarly, I'm going to use manipulation and I'm going to try to spin it around one axis and see if it works. If it doesn't work, then we have other options as well. So you see the problem is right now is trying to constrain both ways. I don't want that. So I'm just going to cancel it and I'm just going to remove this constraint for now. I'm going to delete it and then now I'm going to spin it because I want this part to be out of the way. I'm going to use manipulation. Simply use the part, drag it out, drag it out, drag it out, all the way out. Now I can spin it. Now I'll spin it. Use this and spin it. There we go. Inverse. There we go. Right here. Now we can simply apply coincident and constrain them. Coincident, coincident, update, right? Coincide this with this particular side right here. Update, click OK, update, click OK. Right here, do the same thing at so like at the top, do the same thing, coincide the inside face with this right here, click OK, update, there we go. So there we have it. So that's a complete assembly. So now how can we confirm that what we have done is correct? There are basically two ways. One is using the compass because compass is always going to consider all the constraints that you have made. So this part is supposed to be moving because the bottom is fixed. So this yet with respect to constraints. So what I'm going to do is I'm going to click on manipulation with respect to constraints. Make sure that this is activated. If this is not, then it's just going to act similar to compass. And then I'm just going to click on Z and try to move it. As you can see, it's perfectly moving, and this is how this assembly should be. And the best part is if something is off, you will eventually come to know that some of the parts, if they're not constrained properly, then they will appear to be not normal. But yeah, that's pretty much it for this video. Thank you so much for watching. In this video, you learned quite few things about assembly designing and also about features like constraint, contact, how to use manipulation, and compass as well. So if you want to know more features Please do not forget to subscribe my channel. And once again, thank you so much. Take it easy. Bye.